Hello students, this is Miss Blackwell here. So I can't be with you today, I'm feeling a little under the weather. I did want to go over a few things just to get you started for the day. If we remember from Friday, we started looking at a problem dealing with a roller coaster, and we had to come up with kind of what did that roller coaster's track, if you were to make an equation, what did that kind of follow. And so you'll continue to be looking at polynomials and giving its equation in factored form. The main thing you'll be focused on today is problem 8.2. If you're feeling like you really are stuck on 8.2, you can use 8.2 to 8.6, and I'll kind of walk you through 8.2. So if you read 8.2 and you feel like, what in the world is that asking? Work through problems 8.3 and 8 through 8.6, and that will walk you through. But see, first give it a shot to see if you can try to figure it out before you look at this problem. And so 8.2, right? So what you'll do is you'll break up into teams. That you need to work in teams in this. I can't emphasize that enough. Because there's so many of these problems, right? There's 8 polynomials down here, and you're gonna have to make a graph for them. And so if one person's trying to do all that can be quite a bit of work. So please separate, get into teams, and work together. So your task is, with your team, write a thorough description including examples and justifications of the relationships between a polynomial function and its graph. To accomplish this task, first divide up the functions listed below so that each team member is responsible for 2 or 3 of them. Right, so you should be breaking those up. If there's 4 people on a team, each person should take 2 of those graphs. And then you want to make a complete graph of each of the functions whenever possible, making a sketch without using your graphing calculator, right? So you want to try to do this without using a calculator, without using Desmos, just by looking at what you're given, can you come up with the graph? Then as a team, share your observations, including your responses to discussion points. Then choose 2 or 3 functions that can be used to represent all of your results. And you can choose from this list, or you can create a new function if you so desire, right? You can create a new function to talk about. And you'll create a presentation for the class. So tomorrow, what I'd like you to do is, you guys should be finished kind of a presentation, and then tomorrow at the beginning of the class we'll take a couple minutes for you to present. So be sure to include complete graphs and descriptions. Some discussion points. What can you predict from looking at the equation of a polynomial? We'll get into the point where you should be able to look at, let's say, p sub 7 of x here, and you should be able to tell me some things about this graph just by looking at it, without having to plug it into a calculator or anything. And some of them are going to be a little harder. You might have to, right? So when they're in factored form, you should be able to tell me some things right away. When they're not in factored form, such as 6 and 8, and 3, it's going to be a little tougher. But hopefully, you're starting to make some connections between things here. So, some other discussions that you should be talking amongst your team is which form of the polynomial function is most useful for making a graph, right? So is it easier to graph something in factored form or standard form, right? So which one is it? You tell me. And how can we use the equation to help predict what a useful graphing calculator window might be? And then which examples are most helpful in making the connections between the equations and the graph? And how does changing the exponent of one of these factors change the graph? So some other things to be looking at as you do this assignment, look for and label and describe the x-intercepts. Right? So if you see any x-intercepts, describe them. Are there any bounces? Or we'll call those double roots. Is there any things that go and touch the x-axis and jump right back off? What is the y-intercept of your graph? What is the number of turns? How many times does your graph change direction? What is the behavior of your graph? As your graph approaches negative infinity, does it approach negative infinity? Does it approach infinity? Does it approach a set number? And same with infinity. As it approaches infinity, does it, in the x-axis, in the x value, does y also approach infinity? Does it approach negative infinity? Does it approach a set number? And what are the behaviors of graphs for very large and very small x values? And so hopefully that gives you some thoughts as you are discussing those different polynomials. A couple of things to keep in mind, hopefully jog memory. When a polynomial has a factor of x minus 5, there's an x-intercept at 5, 0. That is, p of 5 is equal to 0. And that 5 is called a 0 of the polynomial. Or a root of the function. And so you want to think about, okay, well, what is the root of the function? Well, that's when your equation is equal to 0. Okay, what is a 0? Well, okay, what do you think it is? Okay, right, it's right when it's sometimes crossing the x-axis. For a real root, it's when it crosses the x-axis. However, there is complex roots where your equation might be equal to 0. And so that's when we're done with complex or imaginary numbers. We'll get into that a little later in the chapter. What is a degree? And then polynomial. I encourage you to read the math note polynomials in this section, and study a little bit more. So, once again, some things to include in the presentation you're creating. What are some ideas of factor form? What are some x-intercepts? What is the effect of repeated factors? And I'll talk about that a little bit more in just a little bit. And then determine the coordinate of points between x-intercepts. And also keep in mind, what is the definition of root, a 0, degree, and polynomial. All of these words should be found in the glossary if you need to reference them. Right, so real root, as I mentioned earlier, that was when it crosses 0, the x-axis. And root, it's just when your equation is equal to 0. You can have complex roots, though, that do not cross the x-axis. I said I was going to talk about, the effect of repeated factors. So a couple of examples, double root. So two roots that share the same root. So when p of x is equal to something like x minus 2 squared, means that the two roots at 2, 0. As you can see the graph, right, it touches 2, 0, and it just bounces off the x-axis. But we say there's two roots right there, and kind of another way we might say it is that's a double root. Triple root, done with cubic function, kind of the same setup, x minus a cubed. Then there's an inflection point at a. I'm showing this example, x minus 1. That means there's going to be a inflection point when x is equal to 1 at the x-axis. And so once you got that presentation lined up, you can work on homework 8A to 821. Hopefully this has been helpful, and once again, I'm sorry I've not been able to be there today. Remember, Wednesday is Pi Day, so hopefully you're remembering that to, get your supplies together if you need. And I hope to see you tomorrow. Bye.